Good afternoon and welcome to Design Master Training. My name is David Robison. Today we're going to be looking at two topics. We're going to start by looking at feeder IDs in Design Master Electrical for Revit. We're also going to take a look at the new features in the 2.1.1 release we have that's currently in beta. So we'll be taking a look at those two topics. If you are attending the training live, you can ask questions in the chat box. If you're watching the recording of the training, you can call or email your questions. Our phone number is 866-516-9497, and our email address is support@designmaster.biz. So we're going to start by taking a look at feeder IDs for single line diagrams. So I've got my single line diagram pulled up here in Revit, and the feeder ID is this annotation here. It corresponds to the feeder schedule that we have over here. So this 100 is indicating essentially a 100 amp feeder, and this is giving us our specific wire size. So it's a mapping, a way to indicate your wire sizes without putting the full wire size on your feeders. Pretty common, most people are using those on their single line diagrams. We have a lot of features built into the software to get those feeder IDs looking how you want them to. Out of the box, we do it one way, but you can make some changes depending on how you like to do your feeder IDs in your project. We go to customization. We can run the project feeder ID schedule command. This will list all of the feeder IDs that have been created in this specific project. And here we can see that all the feeder IDs, they have an ampacity associated with them. They have the ID. This is what's actually displayed on the drafting view. So this is the value that's being shown. We have whether it's an equipment or a service ground, and then the actual wire size itself. And the ampacity, the ground type, and the callout, those three things for each unique set of those, we have an ID. So if any of those changes, we'll give you a new ID for it. So you could have some cases, and we'll take a look at that, where you've got a call out, a wire description that's actually used for different wire sizes. And so we'll have different IDs generated, or we'll have different service grounds being used that have the same wire size, and you'll end up with a different ID. This all, again, ends up being pushed into this ID, which is what's then shown on your single line drafting view. So we've got these IDs here that then correspond essentially to these wire sizes. So for your feeder IDs, if you want to change the feeder size for something, you want to think about it not in terms of, I want to change this ID, but I want to change the settings for my feeder that's going to give me a different feeder size that will eventually change this ID. So you don't say, I want to change this from a 100 to a 200. You actually want to do something different to upsize your wire. So for example, for this PP1B here, if we run our panel edit and select this panel, that call out, that ID here, is being generated based upon the feeder settings. So if you want to change your wire size, you don't want to, you're not changing necessarily the ID, you're changing your settings here, which are going to give you a new ID. So you're changing kind of the more fundamental level stuff, and then the software is generating a new ID for you. As an example, if we take this from a single neutral to a double neutral, we now have two neutral wires, and we've actually got a new wire size because we've derated the wire because we've got two neutrals in there. And it'll see that that's got a new wire size, and it's going to give us that new feeder ID automatically. So we didn't have to go in and change the feeder ID. We just made the change to that feeder to have whatever it needed for our specific instance, and then it updated to be correct. So let's walk through the various options and ways we have to change things here. Just another example of changing a size. If I come in here and I change this to a 200 amp panel, it's going to give us a new wire size. And again, we're going to get a new feeder ID associated with it. You'll notice that this feeder schedule isn't updating automatically. When you make changes in the panel edit, we'll update that panel. We don't update everything every time. because if we did that, you would ask us how to turn it off, because making all your changes every single time you make a change would slow everything down. So we update some stuff, but you eventually want to come run the calculate, and that'll get everything updated. For the feeder schedule itself, if you want to update just that, you can go to DM1 line, run the schedule insert. If it's already in the drafting view, it'll just update it where it already is. So we run that, and now we have that new feeder ID being listed there. In project options, we have a number of options related to feeder IDs. The first one is whether or not you even show these feeder IDs on your feeders. The vast majority of our customers use the feeder IDs, and so this is set to yes by default. If you don't want to show IDs and you want to show actual feeder sizes instead, you can set this to no, and that'll turn them all off for you, and then you can label your feeders with feeder sizes on your single line diagram. So if we change that from yes to no, it's not going to update automatically because it takes a little while, so we'll run a calculate, and that'll get everything to update. And now all those feeder IDs are gone. It gave us that little error message saying that no feeder IDs were located, so it's going to get rid of the feeder ID schedule. So we'll set that back to yes because we need to have that turned on in order to see anything. We also have the feeder ID format. We have two options included in the software, short versus long. For the moment, we're going to leave that on short. We'll come back to that and take a look at it. And then we have whether we create feeder IDs automatically. This is where if we need a feeder ID in the project, if the software is going to create it based on this format and just generate it for you, or if it's going to ask you what that should be. I'm going to change this to no. And what this means is that when we need a feeder ID, it's actually going to prompt us for what that format should be. So if I come in here and I edit this panel and I change it to a 300 amp panel, we're now going to need a 300 amp feeder, and that's going to generate a new feeder ID. It's going to prompt me when I exit out saying, hey, we have this wire call out. This is the ampacity. What do you want your feeder ID to be? It gives us a default value of 300, but we could specify something else. This way, if you have a formatting system that doesn't match what we use, you can manually type them in. We've got a couple other features that we'll see that will allow you to reuse those, so you only have to do it once. But this way, you can manually create them using a different format. You can also check this box to have it stop prompting you and just have it always ask you. That basically toggles that option back to yes to automatically create it. We'll leave it at what it is right now and click OK. And put that feeder ID in for us. As soon as we run a calculate, it'll put all of the feeder IDs back on for us. If I come back here, let's change this format from short to long, and you'll see that we're going to get a slightly different format when it generates a new feeder ID. Make this a bigger panel. We'll go to 600 amps. And so now we're using the long feeder ID format. And so this one is going to have the ampacity, the number of wires, the neutral, the ground, all called out in that feeder ID. So it's just a different nomenclature. These ones are longer, so it's depending on how much space you want to take up with your feeder IDs. Click OK, and that's going to put that on your project there. If I insert the schedule, that's the only feeder ID that's currently displayed, so that's the only one that's going to show up. If we run our calculate, everything will update, so that'll update with all of the values. When you create the feeder ID, once it's been created, it's not going to create it again. So if you change that format or you come up with a different format in the middle of a project, you can kind of end up with a mishmash of different feeder IDs because it doesn't know that you intend what to do with the other one. So it leaves them exactly as they are. It doesn't go back and change them. If in the middle of a project you want to change your feeder ID format, what you're going to want to do is go into your project schedule and essentially erase all your feeder IDs there and generate them again. So we've got this long format and the rest are short. So we've got two different formats happening, probably not ideal. If we come in to the ID schedule, you could come in here, you could manually give them new names if you want to, because you can actually edit them values here. So if we set this one wrong and we want it to be a 600, we could do that here. If you want to change them all from short to long, the way to do that would be to take all of these, delete them. So now they don't exist. So when it needs one, it's going to have to create it, and then it will create it using the new format. So if we go to project options, okay, make sure we're still set to long. Run calculate. So now it's going to have to create all those feeder IDs. It knows it needs it. So it's going to prompt us for each of them. Okay, for the 400, what do you want it to be? For 100, what do you want it to be? And this is where, if you're happy with our formatting, you want to check this box so it stops asking you and just uses the default value. But if we were typing in something different, that way you could, as each one is generated, type in what you actually want that label to be based upon your system of creating feeder IDs. And then once this is done, we will have all of these updated with the new long feeder ID format. So there we go. It finished the calculation. And we've got the different labels being displayed there. In the project options, the next two options we have are copying feeder IDs to the master schedule when created and transferring from the master schedule if possible. These two options exist for when you are creating feeder IDs that don't match our nomenclature. If you're using ours, they're going to get created automatically using our system and everything will work out fine. But if you want to have different labels, you don't want to have to recreate those for every single project. So this first option says, when you create it in the project, copy that one to the master for me automatically. So I'm going to set this back to no so that it prompts us for it so we can do a different label. And if we go take a look at our master ID schedule, it's currently empty, so nothing's in here. If I come and edit this and say we are going to go from copper to aluminum, so we want this to be an aluminum feeder. So now we're going to have an aluminum feeder for this, and we need a new ID. So now it's going to prompt us. We've got essentially an aluminum callout. How do we want that to show up? By Design Master is just going to do a -A, -B, -C when it kind of finds duplicates. Maybe we want to actually call this out a little bit better and say AL for aluminum. Click OK. So now it has that new ID that we created. If we go to the project schedule, the project is specific to this project. It's what we're using for this project. It's not being used anywhere else. We've now got that aluminum one in there. And then the master is going to have that new one that we just created. So it didn't pull everything, just that one that we created when it was created was pushed over to the master for us. This master is a shared file that multiple projects can use. You can also set it up to be shared among people in your company. If you go to customization and user options, we have your customization folder here. By default, it's going to point to your local C drive, to your application data. If you have multiple people in your company and you want to have a standard master database, set of feeder IDs, you can put this on a network drive somewhere, and then everyone will have the same feeder IDs that they're using, and then that'll be shared among people in the company. So the way you can do that is you can run select customization folder, point to it, you can just type something else in, but get that pointed to a network drive, and then everyone in the company can see it. So under project options, we're creating in the master automatically. We then have the other option to pull from the master if possible. So this is when we create one. If it exists in the master, we're going to pull it from there. We're going to go take a look at there, pull it into the project, and then use that. So as an example, I'm going to set that to yes. I'm going to go into my master schedule. There's not a whole lot in here right now, but say we go into the project and I take this one and I delete it. So now we don't have that 600 amp feeder at all. If I come here and edit this, I'm going to change it back to copper, and it's going to go back to that 600 amps that already exists. It's going to use the feeder ID. If we go back to aluminum again, that exists in the master. It doesn't exist in the project at this point. We set it to pull from the master if possible. So I set this to aluminum. It's going to see that that exists, and it's going to pull it from the master, put it in the project for us. So it recreated that using that setting in the master. It doesn't match the default settings that we have. That if we just had it Design Master generated, it would have done that -A. It didn't. It saw what was in the master and pulled it in for us. In the master and in the project, we have this create button as well. This allows you to create multiple feeder IDs ahead of time. Right now, we've been kind of creating them on demand as needed. But if you want to set this up ahead of time, you can do that. Typically, you would probably do this in your master. So we can run our create. I'll come down here, say we want to create our 800 amp feeder IDs. You can choose which feeder IDs you want to do it based upon the number of conductors, the number of neutrals, the types of grounds. So the more checkboxes here, the more feeder IDs that you're going to get created. These are kind of the defaults that you would need. The other ones are more specialized cases, but you could set them up as well if you wanted to. I will create my feeder IDs, and it went ahead and created 12 tags for me. And then it filled them all in here. So now I've got all of the different options for 800 amps created. So this is a way, if we wanted to set up a different nomenclature, we could do that, having created them, and we could come in then and adjust these. For example, by default, equipment grounds, we do a G, service grounds, we do J, because it's a supply side service bonding jumper. So we pulled the J from the jumper because S and 5 are too similar. I didn't want to include that as the default, just because that has the potential for confusion between those two letters. Maybe you're okay with that, and that's totally fine. You don't have to agree with me. You can come in here and change all your J's to S's. And this way you can do it ahead of time so that these are all created without having to have the software prompt you for each of these. That way they're set up properly. So it's a little bit of work to set up the master ahead of time, but then if you do set up the master, you can have your projects based upon that. I'm going to go to this feeder here. Take a look at these two. We've got 200 amp panels, and obviously they've got 100 amp feeders. It's going to be a number 1 wire and number 8 ground. I'm going to edit this panel here. I'm going to make it a 60 amp panel, but I'm going to upsize it to a 100 amp feeder. And you'll see that it's going to give us number 1 wire, but number 6 ground as opposed to a number 8 ground. The reason being that it's a 60 amp panel, but we're upsizing the wire, which and you end up in NEC 250-122B, where when you're upsizing a wire, you have to upsize the ground proportionally. So you end up with a different size ground, in this case, between these two feeders. So if I hit exit, it's now going to prompt us. And this is where some of those different, it's going to use that -A, -B. If you're using the shorts, it'll do a .A, .B for the different feeder IDs when we have a conflict, because we have a different ground size being used. So I'll click OK. So now we have a 100 amp feeder essentially with a -A, meaning that it has, I'm going to run the schedule insert to get it inserted. It has the different size ground, because we need to call out these two feeders differently, because they are, even though they're both essentially 100 amp feeders, they've got different size grounds happening, and we need some way to differentiate that. These graphics, by default, we include 3 symbols for your feeder IDs. If you run the add modify graphic, you can select it. I'm going to replace the existing ID graphic. We're using the hexagon. We also have an oval, and then we also have a rectangle. So the oval is going to look like this, and then the rectangle is going to look like this. So out of the box, by default, those are the 3 feeder ID graphics that we included. They all, if you select it, have a width parameter. So if you want to change the size, you can adjust it here. If we come in here and we type 500, it's going to adjust that width for you. So if you want to have the size of the box different, you can adjust it there. You can also create custom feeder IDs if you want to do something else. To do that, you need to create a new family. So you would run the edit family command, and you'll see our feeder ID. It's actually a little bit on the complicated side in terms of the formatting, because you'll see that we've got the box rotated 2 different ways for a horizontal versus a vertical feeder. These are all on vertical components. We don't have any on horizontal, but if we did, we'd still want it to read the same way. And our families do have the option to move these up and down. So we've got a little control point here where you can adjust where this is going to live. So you can adjust these up and down. If you want to have it on a different segment, we have the graphic move command where you can select this segment and I want to move it over to here, which is actually replacing, and here it swapped that overcurrent protection and the feeder ID, which is probably not what we wanted to have happen, but we could move it from here to this horizontal segment. And this is where, again, the complications of the feeder ID families come into play because it swapped how it was being displayed. So you can modify them. You do have to modify the two different versions if you're going to use our same system. So you actually, these are embedded families. You have to come in here and edit this other family, and then you can make your adjustments there. If you do want to adjust these feeder IDs and you struggle, you probably want to contact our support. We can kind of walk you through that. There's a lot of different steps and pieces involved. And it does require being pretty familiar with how Revit families work, just because that's just the nature of modifying Revit families. But if you're happy with one of our three, the hexagon, the oval, or the rectangle, you can use that. That graphic is actually stored in the schedule under the group. So you can have different IDs for different groups. So if you want to change the group, this is where you change it. You can run edit feeder ID. And here we could change it from a hexagon to an oval. And now we'll go ahead and run calculate to update everything. Now it'll swap out all those hexagons with those ovals for us. So you can do different feeder ID groups, and then the different groups can have different graphics associated with it. So if you wanted to have one group that was your copper grouping that has one format, and then the other is your aluminum, you can have a different shape feeder ID box. So that's how feeder IDs work. We then had a couple questions on the actual formatting of these wire callouts. So the feeder IDs are working on your wire callouts, and then the wire callouts are kind of a separate thing that you want to get right, and then the feeder IDs are generated based upon them. So the first question that we had was, can the order for this callout be adjusted? The answer to that is yes. This is going to be in project options. We have a couple different choices there. We can adjust the conduit location. So right now our conduits are up at the front. We've got 1/2 inch and then the rest of it. You can swap that so the conduits are at the end of the wire callout. If we edit this panel, you can see that we've got the new wire callout there. So that's how we'll test these. So we've got the number 3, the 3-inch conduit at the end. And again, because that's a new format, it's going to ask us for a new ID, because now we've got conduits in the front, conduits in the back. So you want to have this set up right at the beginning of your project, or if you do adjust it, go erase all your feeder IDs so that they're generated with the right format. The other option, I'm going to set my conduit back to the start of my wire, is whether the neutral is called out separately or not. So currently we call out the phase wires and the neutral wires to be separate. You can combine those if you set that to no. And we go edit this panel again. Now it just says it's got 4 500 kc mil aluminum wires. So it's not calling out the neutral. So those are really the options that we have. And again, it's going to prompt us for a new ID because it's got a new call out. So those are the options we have for kind of how the wires and the conduit are arranged. There's a couple questions. What about the formatting of that KC mil? Can we make it be all caps? You can. That is going to be in your wire sizing command. Here is where these are formatted. And so if you want these to be all caps, you would change it here, because we're essentially using this value exactly as it exists. So if we wanted to take this 250 KC mil, I won't do them all, but we'll do this one, KC mil. You change it here, and now it's going to be in uppercase. And so then if we come in here and edit this panel and we choose something that's using 250 KC mil, here, the 250 KC mil is now all in uppercase. So that's how you can adjust that label. And that's how we differentiate copper, which doesn't have anything, and then aluminum. In our nomenclature, we just put an AL on the wire size so that you actually have differentiation on those wires so that it's clear if you're using copper or aluminum. Next question, what if I don't want the neutral to show up on this schedule? And can the neutral be removed from the feeder? The answer is yes. We pull the neutral information from Revit. For better or for worse, we chose to trust Revit to know what it was doing with neutrals. they didn't implement neutrals the way I would have implemented neutrals. Mostly we do that so that if you do a home run and you have tick marks on your home run, that the tick marks are going to match what Design Master is doing. So we basically, because the tick marks are being controlled by Revit, because Revit does graphics, so we wanted to make sure that we were matching their system. So if you want to remove a neutral, it depends a little bit on what kind of wire you're doing. If you go to customization, if you go to help and you go to our help system and you go to advanced topics, we have a neutrals topic because this comes up frequently enough that it's in here. This explains all of the settings that you need to adjust. So for distribution equipment, basically feeders, you do the adjustments in the distribution system settings. So you need to create a setting that is a 3-wire rather than a 4-wire and assign it to that panel. That'll get rid of the neutral. For branch circuits, you actually need to use the wiring types and uncheck the neutral required setting. And then you need to assign that wire type to the electrical circuit. It's not the most obvious way to do it, but that's how it's done in Revit. You also need to make sure that you have a balanced load on that circuit. If it's unbalanced, Revit will throw a neutral in there. So it needs to be a balanced load and the neutral not required on branch circuits, which is essentially light fixtures or receptacles and mechanical equipment. So in this case, for a feeder, we would need to have a panel that doesn't require a neutral. And let's see if I can make that happen. So let's take this EP2. I'm going to run highlight device. Now it's going to go find this device in the Revit model for us. So I can select it here. And then we can go take a look at the settings and I can look at the distribution system. So it's currently using a 12208Y and it doesn't have any other options. Let's take a look at our electrical system. We'll go to our electrical settings, distribution systems. We don't have a 208 without the neutral, so we would need to create one. So it's going to be a 3-phase. And it's going to have 3 wires, and it is a 208 voltage. So now we actually have this without a neutral. Let's see if we can assign that to this equipment here. We can, so we select that. Now Design Master is going to see that for this piece of equipment, we don't need a neutral. So if you go look at the wire size, it's going to give us 3 wires instead of. So that's how you do that for your feeders. There's a question, A for aluminum shows in the schedule. Can it also say C for copper? So it can, and then again, that is where you would need to manually adjust our feeder IDs. And that -A that we're showing, just to clarify, that's just saying it's something else. It's not necessarily saying it's aluminum. So in this case, we've got this 100 amp with number 8 ground, and it needed a number 6. So it's like, well, I need a new one. I'm going to do a -A. So if you don't want it to show up that way, you could give it a different name. So if you wanted to have the copper somehow called out here, you could do that, just adjusting the feeder IDs here. So by default, we're not going to include anything about the material type. You would need to manually do that, and that's why we have the option for the manual adjustment of the feeder IDs. Because again, different people do different things for their feeder IDs. 2 sets instead of 1. What are you looking for in that question? For typically, that's thinking about multiple parallel runs. That's covered in your wire ampacities, where you specify the number of parallel runs that are being used. If you come down here, for the 450 amp wires, we've got 2 runs being used rather than just 1. So that shows up in our software for the 600 amp. It ends up looking like this. We've got that 2 indicating 2 runs of 3-inch conduit with this set of wires inside of it. We're going to switch to our second topic, which are the new features in the new release of the software. The main feature that was included was this new override review command. What this does is it shows you all of the places where you have changed the value off of the default Design Master setting, where we size it automatically for you. And so we will show you all of these different places. This is intended to be a way to back check your project see where you've changed values, and keep track of those values that you've changed for voltage drop purposes or whatever reason that you have. So you can see in this project, we haven't done a whole lot of work in terms of changing values. On this EP1A, we've changed the feeder ID graphic, so we've changed it to a rectangle, and then we've changed the conductor size to 100 amps, and then we've made a couple other changes. So those changes are being displayed here, and if you make another change, it's going to show up. So if I come in here and I go to the switchboard, and say we want to upsize this for voltage drop, we'll go from a 400 amp to 450 amp feeder. So it's going to be a slightly larger feeder now. When we go to the override review, that's now going to show up as a change that's been made. So we now have our switchboard. That conductor size has been changed. We also have this comment field where you can type in whatever notes you want to make to yourself so that tomorrow, 6 months from now, you can remember why you do this. Or when someone else looks at the project, they know what you were doing. So you can say upsize for voltage drop, whatever you want to do. And now when you come back to this override review, you see that that's been increased. You remember why you did that. On the right-hand side, we have a couple of buttons available. If you click edit, it'll pull that piece of equipment up so you can go make changes to it easily. So if you want to adjust that sizing, you could just go adjust it there. We also have the highlight command that will just show you where it is. So if I run highlight, and in this case, it's a piece of equipment that exists in the model and on the single line. So you can ask it to show it in either of those two places. Let's see where this is on the model. So there's that switchboard if you need to locate it. That's the same as what we have in the panel edit and the circuit edit commands, just another place to find your devices as you're looking at them. Finally, we have the export to Excel. What this will do is it'll take this information and dump it to an Excel file for you. You actually have the option. You can either do an Excel or a comma delimited file. So we've got those two formats available. I'll dump it as an Excel file. I've already done this, so it's prompting us to replace it. I'll say yes. Then I can go to this folder, and I've got the Excel file. I can open up that file in Excel, and it has all of those values output to Excel. We also output the object ID. So if you're doing any sort of scripting or work on your own and you know what to do with those object IDs, we have them available for you. So if you wanted to then do some scripting based upon this, that's available as a link to what's happening in the rest of the Revit model. We added a couple other small changes in this release. Under customization, we have the option to import and export all of your customization settings. Previously, it exported everything. Now you have the option to export just certain specific values. So you can export each section of your options. You can export all of your wire sizing stuff. All of that does kind of go together. So you export your wire sizes, your conduits, and your wire ampacities, because all of those are interconnected. And in exporting just one set and not the others gets complicated. And then you can export your transformer over current protection sizes. So you can choose what you want to export, and then you can likewise choose what you are going to import. So if you want to update just one section of your customization, but not everything else, you can do that. So we have the import and export for transferring your settings between projects. This gives you a little more granularity on what is actually getting updated in the different projects. And that is it for what we have in the new release. The main thing that we wanted to get out there was that override review command, and then also these customization, import, export toggles. So not a ton going on, but just some minor updates that you have available. That is currently in beta. If you want it, contact us and we'll send you a link to install it. And then it should be available in the next couple weeks as the official version. It appears to be fairly stable. We didn't change a whole lot. So we've been having a number of people using it for the last 4 to 6 weeks and haven't really had any issues with it at all yet. I was going to say, are there any more questions? If there are, go ahead and put those in the chat and I will keep answering questions as long as you have them. Does having a master customization file in the network folder slow down the speed of the program due to communications over the network? In general, it's not going to, assuming you're working in a local network. If you're in a local network where that network file is in the same physical, on a computer in the same physical building as where you're working, Ethernet speeds are such that you're not going to see any issue there at all. If you put it on a server on the other side of the country, you might see some issues. So you'll want to think about how you are architecting your network at that point, because we do have to obviously go check that when needed. For BIM 360 files versus local files, it's not really going to work on a BIM 360 server. I don't, because essentially we need to have a mapping to it to be able to like see it essentially in Windows Explorer. I'm actually not that familiar with BIM 360 if it lets you see files that way or not. The customization files are not really going to be living in BIM 360. They're going to be living on your company network somewhere. The project file lives in BIM 360. And so all the project stuff is happening that way. But the customization should be somewhere on a folder on your company network. And in general, it shouldn't have any performance issues. Even if it's somewhere remote, we're not actually hitting it all that often. There's a question, can we go over wire callouts for branch circuits? Yes, so we were kind of focusing on feeders just because that's easiest to look at in the single line diagram. We do all your wire sizing for branch circuits as well. I have a cooling tower, and this is essentially a branch circuit. If we run the highlight device and we select this, this is corresponding to this device here. If we select it and run circuit edit, I'm going to check this so it stops prompting me for my feeder IDs. It's on the CTP panel connected on circuit 1. So your branch circuit wire callouts are controlled at the circuit level and at the device level. So this is showing you what this looks like, and you can, for this specific circuit, change your breaker size, change your wire size. So if you wanted to upsize your wire, you could do that here at the circuit level. And then this is going to create feeder IDs the same. And you also can update it at the instance level. So that was the circuit edit. If we run instance edit, this will show you the settings for this specific device. And here you can come in and you can specify your breaker and your wire size. So this is usually pieces of equipment where you're doing that, where you've got, sometimes you got MCA and MOCP, you've got those settings happening. You can start setting those values for your equipment and then sizing your breaker and wire based on them. So that's how we control the wire sizes for branch circuits. Thank you for watching today's Design Master training. Contact us with questions or comments by calling 866-516-9497 or emailing support@designmaster.biz.